Thank you for having me. It's lovely to be talking about at Hashi Days, actually. Sorry, Hashi Talks. I keep confusing those things. There is a kind of evergreen topic that I constantly like to talk about, which is keeping the Terraform secrets safe. So what I want to focus today specifically here is about how to protect your Terraform workflows, how to make sure that you're not kind of leaking any sensitive information. So let's kind of dive into it. So if we look at the kind of general state of security nowadays, we kind of keep hearing about those kind of security breaches and kind of leaks of information across the board. Just looking at some of the recent research, it actually shows that it actually has increased by 8 times in just 2024 alone. And as you can see here, it's just alarming that 95% of the kind of average breaches actually suffer from the crowd-related breaches. And that actually covers 92% of that is actually exposure of a sensitive data. So just by those numbers alone, it should definitely get your attention. And I hope we can actually kind of with this talk make sure that we're at least covering the security aspect of your infrastructure configuration using Terraform. I also had a look at the HashiCorp recent poll survey that they performed at LinkedIn, and it seems like most of those breaches are actually related to security vulnerabilities and misconfigurations. So I think that's should kind of nicely align with what I want to kind of show you today. There's going to be a show demo at the end. I'm kind of worried now because Cami actually said like live demos are great, but sometimes they can go wrong. So well, fingers crossed, and hopefully the demo gods are with us today. In terms of like security, not all of the security breaches obviously are IAC related. But nevertheless, you shouldn't be ignoring them and only relying on relying on security being, your infrastructure being secured through obscurity, because that should never be your only kind of security mechanism in place. So who am I? Why am I here talking to you about security, Terraform, and everything related to that? So I work as a principal consultant at the Scale Factory. We are a consultancy based in London. We were recently acquired by 1010, so we're part of the 1010 group. But we specialize in helping customers working in the cloud, specifically AWS cloud. And we have been working with a lot of migrations, security reviews, and compliance-related work lately. We have done more than 20 migrations in the last year alone, as well as many security reviews and recommendations based on not just migrations, but also the existing infrastructure customers are running. My background is mostly ops. So I've been coming all the way from SysOps engineering through architecture engineering. And as part of that, I ended up as a consultant in AWS space. I've been working in that space for the last 10 years. I've been wearing different hats through my career, and I have to say I've seen different things as well. I'm a really passionate open source contributor, maintainer, and supporter. You can find me in many of communities out there. Specifically, I'm one of the maintainers of the RVCD Helm chart, as well as some other communities where I'm not a contributor, but I'm or a maintainer, but I'm an active supporter of those. Like it was mentioned earlier, I'm also a HashiCorp ambassador and an OpenUK ambassador. Really kind of love participating in those communities because they're quite friendly and open, and just love speaking to you today as well. When I'm not doing all of that, I'm also a fan of hiking and traveling. So that's kind of my passion as well, kind of exploring new things and learning new things through kind of meeting different people and cultures. Feel free to reach out on the socials as well. I'll be in the stream afterwards, but feel free to connect as well. And I'm happy to answer any kind of questions that you might have. So let's kind of break it down from the start. So if we look at your kind of typical Terraform workflow, you would usually, on one side, you would have users, e.g., developers, ops people, DevOps people, and you want to most commonly deploy something, in terms of deploy something to the cloud or anything API related. As you probably know, there are more than 250 providers for different kind of endpoints that you can actually deploy using Terraform configuration. And how the usual kind of workflow looks like between users on one end and your cloud infrastructure on the other end is it would look something like that. It's probably a little bit simplified, but to just kind of establish how the workflow looks like is you would usually write some code initially, and then there are the usual kind of trinity of operations that you do in Terraform. So firstly, you need to init, which kind of initializes your backend modules, plugins, and kind of puts everything in place. And then before you can actually continue, the init kind of makes sure that there is a TF state. So the TF state is literally where your representation of infrastructure kind of store. So when you run your Terraform, you can actually kind of do things like detect drift or make sure that you reconciliate the changes that you have in code and reflect that in your infrastructure. So the first stage is obviously planning, which gives you either the diff of your configuration versus your infrastructure, or what will happen after the plan. And then after you're happy with the plan, which shows you the kind of the changes that are about to happen, you can either apply or destroy. Under the hood, they are quite similar operations with the difference that apply would just go and try to reconciliate the changes kind of produced by a plan, whereas destroy would do the reverse operation. So it would make changes to the state as well, but it will go and destroy everything you have in your infrastructure or plan. So there are different ways how you can run those workflows. So you can either run it from CLI, you can run it as an automated pipeline or a managed offering such as Terraform Cloud or any other offerings. But regardless which one you're using, we're not going to be focusing on that today. But regardless which one you're using, the most common kind of exposure points here would be, first of all, you can kind of expose your sensitive values from code or your repository where you're storing your code. Secondly, you can kind of you need to protect your execution environment. So there are sensitive values that have been either injected through the environment or used in the environment that can kind of leak out. And the third one, like I mentioned earlier, the state file is a really central point where all the information is stored. And in order to kind of do the operations or detect the drift, obviously the sensitive information needs to be stored somewhere. So it kind of we're going to be looking through those three kind of aspects throughout this talk today, and we're going to be trying to kind of uncover some potential remediation that you can do in order to protect your infrastructure code as you go along. So let's look at the first one here. So the first one would be probably the most obvious one, which is sensitive values in your code. So what we're kind of talking about here is about hard-coded secrets and sensitive values in the code, which is probably the most obvious kind of a no-no, which you should be avoiding. We can kind of split the remediation in kind of two groups. So the first one would be like preventative measures you can do. So obviously you can do things like scanning your repository and kind of making sure that there are no secrets found, making sure that you're educating your team on the good practices and good culture. And the second group would be protective measures. So what you can do is things like something like getcrypt, which kind of encrypts your get contents on the fly. It's kind of a transparent operation. Or you can do something like SOPs, which is quite similar to that, similar approach, but it kind of makes sure that transparently encrypts and hashes your secrets within your code, but not the whole thing. You can actually dynamically inject them from the environment. So you can just feed them in as you go along instead of storing them in code. Or what the most common or the industry kind of good practice is, you should probably store them in a sealed environment. Most commonly, that would be an external secrets management store. You can use something like HashiCorp Vault or a managed vault through HashiCorp platform. If you're using AWS, there is Secrets Manager or SSM Parameter Store, and there are similar solutions in other major cloud providers as well, such as Google or Azure. they would have their own flavor of implementation of that. And the key is that you're kind of encrypting your sensitive values at rest and in transit. In order to avoid the kind of human factor of leaking, you should probably kind of do some kind of randomization or automatically generating those secrets rather than just writing them down somewhere. God forbid having a post-it on your screen, right? So with that, let's check the second one. So the second kind of exposure there is, which is usually kind of overlooked, I think. Like when we work with customers, usually people kind of assume that's either managed by the platform, or they just basically don't think about it. So it's output and audit trails. So specifically, when you're outputting things, when you're doing kind of execution planning and applies, sometimes those can be leaked into the outputs of the platform, and you need to make sure that those are kind of not emitted when not needed. Usually they're not. So with Terraform 014, we got the sensitive values, which were introduced back then. What it means is you can actually mark specific variables as sensitive, and those would never be emitted in your execution plans or your apply outputs. The providers have implemented that natively as well. So for example, if you're using, let's say, AWS provider and you're provisioning RDS database, the initial master password that you put in is automatically marked as sensitive, so it wouldn't be outputted, but you shouldn't be relying on provider having that put in place. So just make sure that you're marking everything as sensitive where needed. Just to kind of make it clear at this point, marking values as sensitive, it's still not encrypting them. So they're still stored somewhere. So for example, in Terraform state, and we'll be looking at that specific risk in a bit. And something else that I want to mention at this point as well is responsibility might differ across workflows. As I already mentioned, is if using any kind of managed platform, that might actually be done by the platform, making sure that you're not leaking values, but definitely worth double checking what's happening there before kind of relying that that's being done. So let's move on to the third one, which is kind of the main topic here is making sure that you're keeping your state secure. So like I mentioned earlier, even if you're using something like Secrets Manager or making sure that your variables are marked as sensitive, the values are still stored in TF state, because this is actually used to track and detect any kind of changes when you're applying your infrastructure changes. And it's actually, the way how it's stored as plain text JSON files. So if you have access to the state, you literally have keys to the kingdom, basically. So there are a couple of options. What you can do here is, so the first one is kind of the, when I say native state encryption, I'm referring to if you're storing state somewhere in a remote backend, such as Terraform Cloud, or let's say S3 bucket in AWS, you can actually enable, in Terraform Cloud, that's enabled by default, but if you're using S3 bucket, that's enabled by default now as well. But historically, it was an optional thing where you could enable or disable the encryption at rest. And it's just something to kind of keep an eye on, as well as access to that backend storage. So for example, if you're using something like S3 bucket, make sure that you're controlling who has access to that bucket. Some of you might be thinking at this point, like, oh, why are we not just encrypting state, on the fly? And there are third-party solutions for that. My opinion is they're quite fragile and non-trivial in implementation. So it's kind of introducing additional kind of a moving part where, for example, if you lose a key, which you need to manage, you kind of lose access to the state, thus your infrastructure, which can have devastating effects down the line. And thus, there was with Terraform 1.10, HashiCorp has introduced ephemeral resources and values. And they have been kind of introduced with 10.10 and AWS provider 5.85. So important thing, kind of thinking about ephemeral values they are never stored in state. And by design, they are ephemeral. So they are just temporary values that are picked from infrastructure every time you run Terraform plan or apply. And as soon as they're used, they're immediately flushed from the memory. So they never leave the memory, and they're always kind of kept there. Another thing that I want to mention at this point is it also protects your execution plan as well. So it's never stored either in the state or the execution plan. So just keep in mind that because they're always pulled from the environment, the values in the execution plan might actually be different than the values at the apply stage. So just something to keep in mind. And with the upcoming version 1.11, which currently entered the release candidate stage, there are also so-called read-only attributes coming as well, which can actually help you with some of the constraints that ephemeral resources bring, which I will briefly touch upon shortly. But just something to keep in mind, Terraform 1.11 wasn't released just yet, so maybe not necessarily something you would want to use in the production just now. And there is also provider changes required as well, which, for example, for AWS, the first read-only attributes were actually implemented with provider version 5.87. So I definitely want to make sure that you're using the latest version. So let's quickly kind of go through the ephemeral resources that are currently available. So like I said, there are changes required in the provider itself, and it is down to the provider maintainers to add those in. So as you can see in AWS, there are quite a few of them, such as secrets management, random password, cluster auth, cognito identity, and so on. And there are also implementations in other providers, such as Azure, Kubernetes, and Google providers as well. Something also to keep in mind is they are different objects, the way how it's implemented. So because they are differently scoped objects, they need to be re-implemented in order to be made ephemeral resources. And because you don't want to leak the state, you cannot use them directly with the normal resources, just because if you would use them in the normal resources, that would automatically kind of store the values in the state. Thus, they actually come with some restrictions on the way how you can use them and the way how they can be actually utilized in your code. But the good news is you can actually use all the meta arguments and everything else that you've been using in the regular resources. But at this point, you might ask yourself, like, if I cannot use it with regular resources, where can you use them, right? And the kind of the primary use case for them now is currently injecting secrets in providers or the connection block or provisioners, which you should probably avoid using. So probably the primary use is probably just injecting them in providers, which I will demonstrate shortly. If we look at the next one that I mentioned, which are read-only attributes, they're kind of solving the problem of you're unable to use them in the regular resources. So they also require changes in the provider. But what they're adding is they're adding so-called write-only attributes in your regular resources. So if we look at the AWS provider, as of version 5.88, there are few resources that actually have those values implemented. There is also good documentation on the HashiCorp Terraform developer documentation site, where you can kind of look how that can be implemented. So if you're a maintainer of a provider, you should definitely have a look at that. But for AWS, there are a few resources that already have that, specifically SSM parameter, RDS cluster, secrets manager version, and database instance. So those are probably the most logical ones where you would usually need to inject the password in. The main property of those write-only attributes are you can only write value to them, you cannot read the value, and the value is never stored in the state. So thus, you can actually use ephemeral resource values in combination with those as well, which I will show you just in a bit. So before I jumped to the terminal, just to quickly show you how you can use ephemeral values. So in terms of variables and outputs, you simply just mark them as ephemeral, and that makes them ephemeral. So they would never be stored in state, but they come with certain kind of constraints where you can use them. And in terms of resources, you're going to see the syntax is very similar. So it's kind of defined in the same way as normal resource. You just, instead of resource, you say ephemeral. and then you provide the resource type and then the resource name, and everything else is more or less the same in terms of syntax. But obviously, just keep in mind there are kind of constraints how and where to use it. Like I mentioned earlier, the most common use case is if you have a provider, let's say a Postgres provider, and you want to connect to your Postgres backend database. You can actually use, as you can see here, an ephemeral resource attribute to feed in, such as password in this case. Cool. So let's jump quickly into some code examples. So really quickly, this is the terminal. I already provisioned a database instance and a VPC where this runs. There's some resources provisions, so let's quickly jump into code and quickly just inspect what's there. So if you ignore the random path that I'm going to be using for naming, there are a couple of locals that we have defined here. So first of all, we have database credentials literally just stored in plain text. The second local variable is credentials. Credentials actually stored in the secrets manager as a resource. And the third one is ephemeral credentials stored in an ephemeral resource. I created locals just to kind of simplify the code later on. But those resources actually do exist. So you can see I have a secret that I'm creating, ephemeral resource as well. And then I'm using a MySQL provider because I'm provisioning a MySQL instance where I'm using password credential from the ephemeral value. So, and I'm just using the SSM parameter store as kind of my output, which I will show you later on, just because otherwise the outputs are, like I mentioned, market sensitive, so they wouldn't be shown in my either plans or applies. So we have a database instance provisioned, everything is in. So like I mentioned earlier, the most kind of probably or hopefully legacy approach is you would just pass the database password directly in, which you shouldn't be doing. So let's go ahead and in the first step, we're just going to switch and using the credentials from the secrets manager. And because I'm using the same secret, nothing will change. As you can see, everything is the same. But the difference is where I'm actually getting it from. And you're going to say, okay, you mentioned that earlier, we should be using that from the secrets manager, but like we still need to feed it values. So we probably, and that's still stored in this state. So for example, if, I'm just going to quickly go on. So if we're going to kind of check the resources in the state, you're still going to notice that there is actually a secret manager secret and the version in it. And if we inspect the state, you're going to see that, we do have everything plain text, even those secrets. So obviously, that's not the best approach, right? Even though you might be encrypting the data, the backend, you should probably do security in depth and kind of avoid that. And the way how we can actually do it is you would say, okay, let's just use those credentials directly, right? So I'm just going to try to use the ephemerals, and we end up in an error just because, like I mentioned earlier, you cannot use it directly in the normal resource. So I'm just going to quickly go back. I'm just going to return back to the secrets manager, but I want to demonstrate to you what the most common use case is. What we're going to do here is we are going to use my MySQL provider to connect to the database. But what we're going to use is we're going to use the ephemeral credentials to kind of authenticate there, and those won't be stored anywhere. So if I just quickly save that, I'm just going to apply it again. You're going to notice that it's kind of doing the in-flight plan, and it's just going to create a database in my RDS instance. And as you can see, it successfully authenticated to the instance and created a database. There's something else that I want to kind of bring your attention to as well, is when I said ephemerals only kind of reside in memory during the plan and apply, you can see there are a couple of additional or a few additional steps. It kind of mentions like opening and closing. So what this literally does is when it says opening, it's just fetching the values from the environment. And when it's done using them, when it says closing, it's literally just flushing it from the memory. So it's never stored anywhere in storage. It's just the memory only. And again, if we list the state, you're going to notice there are no ephemeral resources at all in the state. It's just the normal resources. So let's quickly have a look at the second example that I want to show you. And the second example is specifically around the write-only. I don't know why I want to say read-only, write-only values. So in this example, I'm actually using an ephemeral secrets manager random password that is generated. So normally I wouldn't be able to use that in a normal resource such as database instance, but I can use it, for example, in AWS SSM parameter if I specify the value as value_WO. So obviously that has already been applied, but there is a concept how that actually works is because it's never stored in state, obviously it doesn't know when to store or update the value. So in order to kind of refresh the value, what we can do is we can increase or change. It doesn't have to be increased. It just needs to be a change to so-called value WO version. So if you change that value, that actually signals the Terraform that there was a change. I want to refresh that. So what it's doing, it's actually going to refresh the value in the ephemeral resource and put it in and update the SSM parameter secret. So if we check the parameter now, you're going to notice that that was changed. I wish I would show you the original value, but you have to trust me, but that actually changed during the executions. Cool. Let me switch back to my slide deck. Here we go. So just to kind of wrap things up for today, first of all, as we've seen, security is still hard. Even though we are doing that for quite a long time in our industry, it's still hard. Please pay attention to the basics. Protect your crown jewels. Make sure that you avoid the usual pitfalls, as well as making sure that you are protecting your storage and encrypting it. By storage, I mean state. And make sure that you're using the new ephemeral values, resources, and the upcoming write-only attributes, which will help you achieve that. Use multiple layers of security, like I mentioned, defense in depth. So it's not just enough to do one thing. And also remember, it's not just a technical problem, it's also a people's problem. So make sure that you educate your team and the people involved in the process, and make sure that they're aware of the good practices, and they're not just kind of doing it for the sake of compliance. So keep in mind that compliance is not necessarily equals security. And at this point, just to kind of wrap things up with the words of the famous philosopher Werner, dance like nobody's watching, but encrypt like everybody is. Thank you again for your attention. I will be hanging out in the chat afterwards, and feel free to reach out. Thank you.